the incidence of a certain disease in the town of Springwell is 4%. A new test has been developed to diagnose the disease. Using this test, 90% of those who have disease test positive, while 5% of those who do not have disease test positive. If a person tests positive, what is the probability that he or she actually has a disease? So we would use Bayes' theorem to answer this question. Say, let's first denote, like, say, for a person being test positive, so let's say represent by TP, and the person having a disease, so let's say represented by the letter D. And we have to answer this question like this: what is the probability that person has a disease? So probability of D, given that the person tests positive, that's a given condition. And by Bayes' theorem, so this would be equal to probability of TP, given that person has a disease, times probability that the person has disease, divided by that the probability of TP given that person has a disease times probability that person has a disease, plus probability that person tests positive but person doesn't have a disease, so D complement, times probability that person doesn't have a disease. The next thing is we have to just fill in this information. And person with the disease test positive, so their chances are 90%, so that's 0.90, and probability of disease, PD, so that's chances are 4% here, so 0.04. Alright, so it's the same term in this denominator here, so 0.90 times 0.04 plus that this one here, the person doesn't have disease but tests positive, that's about probability of false positive, and that's 5% here, so 0.05, and multiply with the probability that person doesn't have a disease. So probability of disease is 4%, so it means that remaining 96% would not have a disease, so that probability is 96%, or 0.96. And this is approximately equal to 0.429.